and this is the next chapter, which is more issues in input and output. We have already seen about the console input output and the file input output, but there are more things which helps our input output operations to look more elegant. ARGC and ARGV. This is argument count and these are argument variable. So if we have a program, say copy of one file content to another copy. So what we did, we first wrote the program, compile it, execute it. The program can be improved in certain ways. First, why to compile? Why to compile the program again and again? We can just use the command prompt provided by various operating systems and just like this, C:, and we can run the executable version directly. The second is, rather than taking the input as you can say hard coding, because you are inputting the file inside any program by yourself. But how about just running this program, if the name of the program is file copy, running the program such that you input the copy, input the name of the first file and second file, you need to copy the content from this file to this file, and these two are arbitrary. You can give any file name here. So this is how we can improve the program. So how to get these things done? The first improvement is, as I said, that the operating system provide you the command prompt. So if you have an exe, you transform your program, it is running successfully in an exe, you can just use the name of the program to run it. The second improvement is passing the argument to main. Main is a function. Main is essentially a function because you can see this is the round brackets, and see how we use the file name, that is the source file name and target file name in this program. This is stdio.h. This is argument count and argument variable. Now, this is an integer. So this is counting that after this, how many strings you are going to give. First, this is argument count. If this is 3, it will be 3. If this is 4, this is 4, like this. And these content 1, 2, 3 will be put inside a character. This is actually a character array, a pointer to string. These names, they are traditionally used, and I can tell you that you can use your name also, your friend's name, because this is just the names. You can use any name here. So let us see the program of copying one file's content to another. These are two pointers. This is character variable we have taken. Now argument count, it is always a good idea to previously check, or before we can do anything, just check the number of arguments. If it is 3, because we are expecting 3, the name of the file, the source file and the target file. So that is 3. If it is not the case, we come out. We try to open the first file. As I said, that first will go in ARGV0, the second will go in ARGV1, the third one will go in ARGV. First is 0, 1, then 2. So this is the file name. So 1 we have to take. ARG1, this is the name of the source file. If it is not opening, we raise some concern. This ARGV2 is the second file. Again, we raise some concern. If they are opened properly, then we can just say fget c. All the characters one by one we take, we check for end of file. If end of file is there, we come out. Otherwise, we just put c in the target file. So we are taking from the source file each character and copying it to the target file, and we close it. So as you see here, ARGC, ARGV, as I said, they are traditionally named. ARGV is the array of pointers to the string, and ARGC is an integer, which is actually the value which is equal to the number of strings to which ARGV point. This program entirely depends on main, because you are running main. That is why you are able to run it on the command prompt. ARGV0 is the name of the file. ARG1 is the next string, that is the source file, and so on and so forth. This ARGC is the number of strings which you are going to give in command line. In this case, 1, 2, 3. So there are 3. Argument count will be 3, and the first 0, that is ARGV0, is the name of the file or name of the C file you are going to run. This is the exe version. ARG1 is the first file, the source file, and this is the target file. So we are passing the arguments. As I said, whenever we are passing, it is always a good idea or a habit to essentially check the number of arguments. That is why we are checking here. Argument count is not equal to 3. We say improper number of arguments, and other things remain the same. So what we got, there is no need to recompile the program again and again. You can just use the command prompt. Then we are able to pass the source file and target file name or any other content in main by ourselves, rather than giving it inside and fixing it inside the program. Let us do it by ourselves. Arbitrary file names can be given. There is one more thing. We have used an indefinite while loop. Now you can use the compact form. How? While you are getting fget c from source file to ch is checked for end of file, and if it is not end of file, you just put the character one by one in the target file. So we are not using indefinite loop or a break state, right? The first, this fgetcfs gets the character from the file and it's just assigned to the character. Character is compared with end of file. Please remember, it is necessary to put this inside a round bracket, inside a parenthesis. Otherwise, the idea of this command will change. There is another way of writing the while loop. This is how while. This is not FEOF. This is very important. FEOF. So while not FEOF, FS, you are getting the content from the source file and putting it in the target file. This FEOF is a macro which returns a 0 if end of file is not reached. So it returns 0, not reached. So this not operator is used to negate this 0 to the truth value. So not of anything other than 0, say 5, or when the end of the file is reached, this FEOF returns a non-zero value, and this not will make it to 0, and the condition is going to evaluate to the false, and the while loop get terminated. And just see one more thing, that the three methods are same. If you open fopen with the name of the file and this mode, it is okay. You can put the file name, the variable, and open it, or rather you can just use argv from the command line. This is very important to detect the errors in reading and writing. So whenever we are performing the read and write operation, always the reading and writing may not be successful. So we need to find out the errors. This is very good programming. So we have a standard library function which is called as ferror. This ferror will report any error that might occur during your operation of read and write to the file. So it returns a 0 if the read write is successful, or a non-zero value in case of a failure. So we'll see a program which will illustrate this error. See, this is stdio.h. We need to include it. We have a file pointer, we have a character. Then this is the fopen, the file name, and we are writing it, trying to open it in the write mode. So this will be open because there will be nothing. If it is in write mode and if it is not existing, even if it is existing, it will override the content, so there will be no content at the first. So what we are doing here is, we are checking file, end of file, FP. We are getting one by one character, and then we are checking for error. We know that error is going to happen because we are opening it in the write mode. And whenever we are reading, there will be an error. So this error, we are saying printf error in reading file, and we break. Otherwise, we can just print the ch and we close. Here, in this program, this fgetc function is going to obviously fail for the first time because we have opened the file for writing. While this fgetc is attempting to read from the file, and that time error will occur. That moment the error occur, that is f error, will return a non-zero value. It will return a non-zero value, and this if blocks will get executed. So instead of just printing the error message using the printf, we can use a standard library function again, perror, which prints the error message which is specified by the compiler. So this program using the perror will run like this: if f error, then perror, trial, and break. Just see that when the error occur, the error message is displayed like this. So this is going to mean that it will precede the system error message with any of the message which you want to give. Okay. Standard input output devices. Whenever we are performing the reading and writing operation, we used fopen, which is actually setting the file pointer to refer to the file. And most of the operating system, they have predefined pointers to the 3 standard files. And in order to access these pointers, we need not to open them again and again with fopen. So these standard file pointers are like this: stdin, this is for standard input device; stdout, this is for standard output device; stderr, this is for standard error device. So this statement, which is ch, which is getting fgetc from stdin is reading a character from the keyboard rather than a file. So we can use this statement without the use of fopen or fclose. Then most of the operating system, they provide standard file pointers like these: stdprn, the standard PRN printing, this is for printing device. This is stdaux, this is for standard auxiliary device, which is the serial port. So let us see the program. It reads a file from the disk and it will print it on the printer. So this is printing the file contents on printer. This is stdio.h. We have a file pointer, we have a character variable. Now we are opening fopen, this poem.txt in read mode. If it is not opening, we raise some issue. Otherwise, we get C or get a character from FP, check it for EOF, and just fput c ch2 standard printing. So this is how it prints directly to the printer. So this statement fput c ch2 stdprn, it writes a character which is read from the file directly to the printer. So we have opened the file on the disk, we didn't open stdprn, the printer. So standard files and their use of redirection, we will be talking about them shortly. Just note that these all standard file pointers, they are defined in stdio.h, so it becomes necessary that you include this file in order to use this standard file pointers. Input-output redirection. Please observe carefully this sign and this sign. These are the signs which are used for redirection. They have very powerful feature, operating systems. Even when such capability has not been incorporated in the program, they provide you with certain capabilities, and this is done through the redirection. What happens is, C program generally receives the input from the standard input device, which is assumed to be keyboard, and it will send the output to the standard output device, which is assumed to be a VDU. That is, operating system assumes where input should come, from where input should come, and where output should go. So this redirection permits us to change this assumption. For instance, you're using redirection, the output, if you use the indirection or redirection, the output of the program that normally goes to the visual display unit or your monitor can be sent to the disk or the printer, right? Even when you have not made any provision in your program, and this becomes quite a convenient and flexible approach, right? Providing separate function in the program to write to the disk or printer, you don't require it. Similarly, redirection can be used also to read information from the disk file directly into the program. That is, instead of just receiving the input from the keyboard. In order to use redirection facility, this is we want to execute the program from the command prompt. Inserting this redirection symbols at appropriate places is important. So let us see these with the help of the program. We are redirecting the output. How to redirect the output of the program? We'll take a program from the screen to the file. So let us have this program. This is util.c. You have to use this. This stdio.io.h. You see, there is something here. So this is character ch. We are getting from standard input one by one character and checking it for end of file, and we are putting the character one by one to the standard output. Here, when we compile the program, we have util.exe. So when we execute this file, this putc function will cause whatever we type to print on screen until we type the Ctrl-Z. This is the termination of the program. So Ctrl-Z character, this is a sample run of this program. This Ctrl-Z character is often called the end of file character. So if you just take util.exe, it will show you this with Ctrl-Z. Now, let us see what happens when you are invoking the program in a different way using redirection. So you have util.exe. After that, you have used this redirection operator, and this is the text file. So this does what? We are trying to take the output to be redirected to the file which is poem.txt. So can we prove this, that it is indeed going to poem.txt? You can use a type command. Just use type with poem.txt. The same content would come. So this result, or there's the result of our typing sitting in the file, the redirection, this one, causes the output or takes the output intended for the screen, the video, to be written to the file whose name follows the operator, this one. And you have to see that the data to be redirected to a file doesn't need to be typed by the user at the keyboard. The program is doing by itself, and any output which is sent to the screen or you can say the video can be redirected to a disk file. Let us take an example which is generating the ASCII table on screen. So this is ASCII.c we have main. This is a character variable, and from 0 to 255 ch++, we're just printing CH, and this in the integer form, the ASCII form, and this is the symbol. So when we execute this program, or when we compile this program and execute it, we use it using the redirection operator. This is ASCII.exe. Now we're using this redirection operator, and we have table.txt. So the output is written to this file, and you can just capture the output in a file rather than just displaying it on the screen. How helpful is this? So there are various pre-definition from the operating system, the number of file names for its own use. One is PRN. This is standing for the printer. So now you can output or you can redirect to the printer by using the file name. So if you invoke this ASCII.exe, which we have just seen, like this ASCII.exe, and you use this redirection operator with PRN, the ASCII table will be printed to the printer. Now how to redirect the input? So we can also redirect input to the program. So instead of just reading the character from the keyboard, a program reads it from the file. So let us see how it is done. So in order to redirect the input, we need to have a file containing something which is to be displayed. Some content has to be there. So suppose we have a file called this, and it contains some lines. So we'll assume that using some text editor, we have placed content inside this, and we use this now in this input, this operator before the file. So we have this C util.exe. Now this is the operator for new poem.txt, and this content will be shown. So the lines are printed on the screen with no further effort on our part, and this using the redirection, we have made our util.c or util.exe perform the command function, which is the type command, because it is showing the content. You want to use the redirection operator inputting and outputting, you can use them together. So redirection of input and output can be used together. The input from the program can come from file via redirection at the same time, and the output also can be redirected to a file, and this program is called as a filter. Let us see a command. This is our program util. This is new poem.txt. So you are taking the content of new poem.txt and transferring it to poetry.txt. So in this, the program received the redirected input from the file which is pointed by this one, instead of just sending it to the output or a video, and it would redirect to the poetry.txt. And we can also send the contents of file this one to the printer. How? Take the content in the util and transfer it to the PRN. So we can use the multiple redirection, but don't try to send output to the same file from which you are receiving input. Why? This is because the output file is erased before it's written to. So by the time you are trying to receive the input from the file, it is already erased. So this is a very powerful tool for developing the utility programs, especially if you are dealing with data, examining and altering the data in the file. So this redirection is a very good idea to establish relationship between a program and a file. There is one more operator that can be used to relate to programs directly, which is the pipe operator, right? So that we can output one which is fed directly into another, and with no files at all involved in between. This is the piping, and this is the operator we use. This is called the pipe. So let us summarize what we have seen. We can pass the parameters to the program at command line using the concept of command line argument. The command line argument argv contains the value passed to the argument. This is an array, string array pointer, or the character array pointer to the string. This argc contains number of arguments, and we can use the standard file printer. This is stdin to take input from the standard input device like the keyboard, and we can use this stdout standard file pointer to send output to the standard output device such as your screen or a monitor. We can use stdprn or stdaux, these are the standard file pointer, to interact with the printer and auxiliary devices. Redirection, these operators less than and greater than, this allows the program to read from or write the files at the command prompt. These are the operators which are called as redirection operators. So this is the discussion about this chapter. Thank you so much and take care of yourself.